So after having the basic idea about the data and its plotting and visualization, now it is time to start with the machine learning algorithms. In the first part, we will see the supervised learning, and the linear regression is the first algorithm which we will see under the supervised learning method. Linear regression basically attempts to model the relationship between two variables by fitting a linear equation to labeled data. So we'll see it in the next slides how this linear regression works. Some of the key points to remember: linear regression is a supervised machine learning technique. It works on labeled data. It is mainly used for predicting a value. And you can say that main purpose of linear regression is to find y for the given x. Let us understand it with some sample data. So this table is taken from the housing.csv, where you have 5 columns: bedrooms, bathrooms, square foot living, floors, and price. Each row indicates a house characteristics and its price. So say for example your row number 1 says that a house having 3 bedrooms, 1 bathroom and 1180 square foot living with 1 floor was sold for 2,21,900 US dollar. Similarly, all the rows are showing you the type of house and its price. Now we want to work on linear regression, so let us divide this data into two segments. So initially I say that my first 4 columns are the X for me. So I'm calling them the features or the attributes for my data. So your housing price is dependent on the type of features your house has or type of facilities your house has. So say for example, a house price can be predicted or can be derived based on the condition or based on the facilities available in the house. So you can say that your price is dependent on the first 4 columns. The second segment of the data is our price, and we will call it small y. So we want to predict y for the given x. Now we are working on the supervised learning. So we have the data which is already labeled. Each of your row has a price. It indicates that for a particular type of house, the price would be this. And based on this, we want to apply the model and we want to predict the housing price for the unknown data. So we want to create a relationship between x and y in such a way that for any given set of x, you can predict the y. Let us further divide this data into two parts, because while we talk about the supervised learning or labeled data, we will need to train the model. And once you are training the model should understand the behavior and relationship between x and y. I have first 10 rows of the complete data set, so I am dividing it into two parts. I am taking the first 8 rows of the X dataset and I'm calling it X train, and similarly I take the remaining 2 rows of the X dataset and I call it X test. For the Y, we are repeating the same procedure. We are getting the first 8 rows and we are calling it Y train, and we are taking the remaining 2 rows and labeling that as Y test. Now the purpose behind dividing this data into X train, Y train and X test, Y test is that once I fit the model with the training data set, I will need to evaluate my model, whether the model is working properly or not, whether its accuracy is good or not. So what I have done, I have kept 80% of my data, which are the first 8 rows, into the training data set and remaining 2 rows into the test data set. It means that I will train my model with 80% of data. Then I will ask the model to predict the value by passing the X test, and then I will compare the Y test which is available with me with the values predicted by the model. If my model predicts the accurate values or very close to the Y test values, then I can say that my model has been fitted well and it can do the things very well. Let us understand it mathematically. So your data is basically shown on the plot. This is a complete scattered data. Each point on the plot shows a value. So we want to derive a relationship between x and y. You can say that your y is a function of x and y is dependent on x. So what could be the equation? One of the equations we can think about is a linear equation. As we are working on linear regression, let us consider a linear equation like y is equal to mx plus c, where there is a relationship between x and y denoted in the form of a line. So if you want to see this on the plot, you can say that I'm drawing a line on my plot which derives or which generalizes the relationship between x and y. Now once fitted, based on the training data, model will be able to identify and remember the relationship between x and y. So for the future data, which is unknown data or unseen data for the model, if you pass any value, if you say I have the set of features as labeled as x and you predict the y, the machine, based on its experience and based on its learning, will predict a value of y which can be used in your real life application. So you can draw any point on the graph and it can derive the y for the corresponding x based on the line it has fitted. Since the mathematical formula and its derivation is beyond the scope of this course, we will not be discussing it in detail. However, we will see the practical implementation of linear regression in the next video.